Hello everyone, we are going to start with A1 kinematics in this particular video, and in this short video we are going to cover some basics of kinematics and introduction to SWOT equation, how to use them in different contexts. In subsequent videos we will discover some more details about this chapter. So let's start. This is the guide, what the syllabus guide expect from us to know. Okay, so we need to know the velocities, distance, displacement, and what are the factors, how to calculate them, what are their definitions, what is the difference between instantaneous and average velocities, and the SWOT equations. So we are going to cover that part in this first video, and then we will talk about more details in the subsequent videos. So let's start with distance versus displacement. So if I start with distance, let's first define the distance. Distance, in a simple words, can be defined as the length of the path covered by the object which is traveling between two positions. Okay, and for a displacement, it is defined as length of the path, more specifically, length of the shortest path between initial and final position. Okay, now one more difference is this. So this is a scalar quantity, so which has only the magnitude, and the other one is the vector quantity, which has magnitude and direction. So to clarify this concept, I will like to give an example of a simple two-point motion from A to B. Let's say the path from A to B is around a semicircular path. Okay, this path has some radius r. Now, if I want to calculate how much is the distance traveled going from this path from A to B, the distance here will be half of 2 pi r. 2 pi r is the circumference. This is a semicircular. So it will be just pi r. That will be the distance covered. But if I talk about displacement, this is the distance covered. And if we talk about displacement, the displacement will be a straight line from A to B. And that will be the measure of diameter, that will be 2r. So this is how the difference between a distance and displacement is calculated. Like for example, if I'm looking at a particular location on my Google map, the Google map tells me the distance rather than displacement. But imagine you're going from A to B in a straight line, let's say through a aeroplane or some helicopter. So that will be the least or the shortest path between those 2 points, and it is a vector quantity. So it has a direction, whether it is going from A to B or B to C. Okay. Once we understand the basic difference between the distance and displacement, or we can clarify that it doesn't matter uh, which direction we move, but the distance can never be zero or negative. Distance can never be negative. In case of displacement, it can be positive or negative depending on direction of motion. Okay. Once we understand the basic difference between distance and displacement, we're going to talk about the distance or the difference between another two quantities, which are speed and velocity. Now again, both of these quantity are highly correlated. The definition is given as the speed is distance covered in given time t. Okay, while velocity is the rate of change of displacement. Now, in speed, we can write a formula: speed is equal to a distance upon time, while velocity can also be written as rate of change of displacement over time. So this is delta s, and then we say rate. So this can be calculated like this. So both of those formula are relevant, and the unit is meter per second. But the more important difference is speed is a scalar quantity. So it only has the magnitude, while the velocity is a vector quantity. So it has both magnitude and direction. Okay. So speed and velocities are two highly related. The velocity, if we take only the magnitude of that, we will always get a speed at that particular point. Okay, if we are only taking the magnitude. Now speed can never be negative. Like distance can never be negative. So a speed can never be. But velocity depending on direction of motion. So usually when the object is moving to the right or upwards, I usually take positive velocities, and if the object is moving to the left or downwards, I can take the velocity to be negative. Okay, so it depends on direction of motion. Now this formula, we have to be aware that this formula is only valid when acceleration is 0. Okay, and we will come to what is the acceleration. So this is the case where we can use those formulas and it will generate a correct results. Then we want to calculate one more important quantity, that is acceleration. So acceleration can be defined as it is the rate of change of velocity. So any acceleration can be calculated by finding change in velocity over time. Or we can write this as v minus u over t, where v is the final velocity and u is the initial velocity. Okay, the unit of acceleration is meter per second square, and acceleration tells us whether the velocity is changing in what direction. So it is also a vector quantity. It is a vector quantity. And one more important thing, that it can be positive, negative, depending on the direction of the motion. Okay. Now, what we need to know about accelerated motion. Okay. So for the motion with a constant acceleration, or a motion with uniform or constant acceleration, any problem of the motion can be solved for this guy is by using Sword equations. Okay. Now, existence of those equations can be learned if we explore some graphs, but for now, we can directly use those Sword equations for S is equal to. So those Sword equation I will write S is equal to ut plus half at square, where S is the displacement. Then again, one more equation for S without any acceleration. If we have the data, we can use this. Then we have v square u square plus 2as. And the final one is v is equal to u plus at. So depending on what values are given, but there are 5 variables, out of which 3 are required to figure out other 2. Okay. Now we want to also know that what if the acceleration is not constant, or if the acceleration or if there is a constant acceleration, how can we find the total change in speed? So we have 2 important terminologies that we want to explore here. That is, one is average speed. Now, average speed is calculated by taking total distance traveled by an object over total time, while average velocity can be written from average displacement or average change in displacement, we can say, over total time. Okay. Now we also have instantaneous speeds. So that is a speed at a particular instant of time. So if the speed is continuously changing, we can take at a particular point what is the speed, so that gives you instantaneous speed. We'll explore this instantaneous speed and how the average speed and average velocity can be calculated using graphs. Uh, it is much more easier, but for an instantaneous speed, we need to know that it can be found by or can be determined by taking gradient of a tangent passing through a particular point. Okay, so this is the instantaneous speed. We can find it from the graph. We can find it from the information given. It is the speed at a particular point or particular instant of time. So once we know the basics of this chapter, okay, I would like to explore few of those examples where we can use those equations or the concept given. Okay, now what are those examples? Quickly, we will talk about one of the examples that are like, for example, there is a person in a car A that is moving with a velocity v is equal to 10 meter per second in this direction, horizontal direction. Okay. At an instant, there is a car B, who is at the rest. Now, when car A passes car B, the velocity is constant for car A. The car B starts to accelerate. Okay. So B is now accelerating. Now we have to find at what instant of time or how much time it will take for both of the cars to meet at a particular point. Because what will happen when this car A passes this, the car B will just start from zero. So it will gain some velocity after some time. And then meanwhile, the car A has moved forward. So we have to figure out when they will meet at the same point. Okay. So this is a position where both cars meets. Okay. So we can calculate this. Let the acceleration be, let's say, 2 meter per second. Okay. So all the information is given. We have to calculate the time where both the car meets. Okay. Where both car meets. Now we need to know that since the car B has started moving exactly when car A passes through it, when they meet at a particular point, the distance covered by the both cars is equal. So for car A, we can calculate the distance covered because it has a constant speed or acceleration is 0. The distance covered will be the velocity into time. So for car A, the distance will be 10 meter per second and the time is t. Let the time be t. Now for car B, the displacement or the distance covered can be given as s is equal to ut plus half at square. So it is starting from 0, u equal to 0. It will be s is equal to half at square. And s will, so a is given, so s is half into 2 into t square. So this will become t square. Now we have both the equation and this distance is d. Because both the distances are equal, what we can do is we can equate, since both distances are same, we can write 10 times t is equal to t square. And this gives us t to be equal to 10. Okay, so it will take 10 seconds for both of the car to meet at a particular position. And we can use this 10 to calculate how much distance traveled by the car A. We will get that value as well. Okay, so this is the one example. Now another example that we will do quickly is the object falling under the influence of the gravity. So if the object is thrown upward, let's say the velocity was u is equal to 20 meter per second and it is at height of 100 meters. The ball or the object will go up and come down before it hits the ground back again. Okay. Now the question here is find the max height, then the time taken to reach the bottom, and the velocity at the bottom. So in this scenario, we can quickly explore that. I can break down the motion in three parts, A, B, and C. Now, if I'm just caring about my motion from A to B, I always make the use of SWOT equation by making a table. Now, if the motion is happening in y direction, the height it will gain is h. So it will be h. Initial velocity is 20, final velocity will be 0. So we need to know that the speed at the top of a projectile, in vertical speed, specifically vertical velocity at the top of the projectile is 0. Acceleration will be negative g, that is negative 9.8, which we can take it as negative 10. And time is something that we need to find. Now here our main purpose is to find the height. So I can use s is equal to ut plus half at square. So s is h, u is 20. Now time t we don't know, so we can't use those equations. So whenever we are choosing an equation, we have to choose the equation that will give us at least like there should be only one variable in that equation. So the ideal equation that should be used is like something that is without time. So like something like v square u square plus 2as. So it will be 0 is equal to 20 square minus 2 into 10 into h. From this, we can calculate the height h. It will be 20 square over 20 and it will be just 20 meters. So like this, we can calculate the height h. Apart from this, from B to C, we can again make a table for the SWOT equation. We're talking about in y direction. The s is, this time it is 120 downward, so it is negative from B to C. Okay. Then let's say we can directly find from B to C, or we can directly use our knowledge to take it the equations, find the equation from A to C directly. So from A to C, if I'm talking about SVUAT, what you can do, the displacement would be just 100 in negative direction from coming from A to C directly. From U to C, the initial velocity is plus 20 because it is upward. Final velocity, we don't know, so I will keep it as V. A to C. Acceleration is minus 10, and the time is something that we need to find. So only three quantities are known: S, U, A, and T. A. So we can use S is equal to UT plus half AT square because there is only time as the variable. So this will be negative 100 is equal to 20T minus 10 divided by half T square. Okay. So in this, we can calculate T by solving a quadratic equation, and that quadratic equation will help us find the T. Once we get the T, what we can do is we can use V is equal to U plus AT to determine the final velocity. Okay. So just before the ground, we can calculate this final velocity, okay, by using this same equation. So once we have done this, we can see different cases. We can probably get different quantities and we can calculate this. But this is how we use word equations to calculate different quantities, and we will look in deep about how to correlate them using graphs in the next week. Thank you so much.